All right, guys, we do not have a warm-up today or a lot of practice problems just because these are the two videos and tasks that we have for this week. They're just a little more involved. So if you weren't able to print off this unit circle, I did attach it to this task. You'll be using it this week, next week. So if there's any way you can get a printed copy, or if you need me to mail you one, just let me know. It'll be really helpful. So I'm going to be using it. I'll be pulling it in and out today on the video because we are going to use what we know about unit circles, mostly with radians, because this is pre-calc. So you kind of, the difference between Algebra 2 and pre-calc is you start talking more about radians because that is what you would use in calculus. So we're going to start looking at finding exact values using radians and predicting other values by knowing what we have on the unit circle. So if we look at this, what are the exact values of cosine pi over 4 radians and sine pi over 4? So you would come to your unit circle and you would find pi over 4, which is the same as 45 degrees, and you would see, we know that x and y is cosine. So this is cosine of theta, this is sine of theta. So we would say that cosine of pi over 4 is root 2 over 2. And we would say sine of pi over 4 is root 2 over 2. And if they asked you to locate, you could say, well, this is pi over 4. It's in quadrant 1 of my unit circle. And it's important to note that this is quadrant 1 because note that they are both positive and both x and y is positive in quadrant 1. And they usually designate quadrants, whoops, forgot my T, with Roman numerals. All right. We're not going to do a lot with calcs and radian modes because we're just going to do things that are on the unit circle this year. But there is a mode in your calculator, so if you were finding inverse with degrees or radians, you would need to make sure you had your calc in the right mode. All right, I want you guys to try this one on your own. So go ahead and pause this video, and then when you come back, we'll do it together. Okay, so 7 pi over 6. We know that if we make it all the way here to 180 degrees, that's pi. So I'm expecting to find 7 pi over 6 in my third quadrant. So this angle here is 7 pi over 6, which just means that this is pi over 6 between my x-axis and my terminal side. We call this the reference angle. So even if you didn't have the unit circle, you should be able to figure it out because pi over 6 is 30 degrees, and we would be able to figure out in general what our points were here. But we are lucky because we are in online school that we love so much. So we're just going to come here to our unit circle and say, oh, 7 pi over 6 or 210 degrees. What are my values? Well, negative root 3 over 2 and negative 1/2. So I could say that cosine of 7 pi over 6 is negative root 3 over 2. Don't forget your negative because both x and y is negative in the third quadrant. And we know that sine of 7 pi over 6 is a negative 1/2. All right. Moving on. All right. Here you go. Here's a few more to try. Be really careful when you're looking at these. Notice that on B there's a negative there. And so when we come back, I'm just going to write the answers in. All right, you should have taken some time to get that in. So at pi over 6, we know that the cosine value is root 3 over 2. And the sine value is a positive 1/2. Pi over 6 is right over here. Negative 3 pi over 2. If I had gone positive 3 pi over 2, it would be here. So I'm going to count backwards. Negative pi over 2, negative 2 pi over 2, negative 3 pi over 2. So I'm up here. That's my negative 3 pi over 2. So if I drew that in, it would look like this. And at that value, I know that cosine of negative 3 pi over 2 is 0, and sine of negative 3 pi over 2 is 1. And just remember that negative 3 pi over 2 is coterminal with pi over 2. And then last but not least, 5 pi over 4 actually is just on your unit circle. So you guys should have noted that it was in the third quadrant. It's this 45-degree angle between your x-axis and the terminal side. And those points, I'm just going to write them in down here, is negative root 2 over 2 and negative root 2 over 2. We know this is cosine and this is sine. All right. That's really the basis for this task 1 that we want to really get down, is that there's only a few different values on the unit circle because there's only a few special right triangles that we put in there, the 30, 60, 90 and the 45, 45, 90, and they all just have specific values associated with them. Right. So we have been using reference angles all along, but we just want to make it more specific now. So if we're talking about any angle in standard position, meaning there's an initial side and there's a terminal side, the smallest angle, or the acute angle, so remember acute is less than 90 degrees, formed by the terminal side and the closest x-axis is called the reference angle. So if you're here in the first quadrant, your reference angle is just theta. Notice if you're over here in quadrant 2, your reference angle is between the terminal side and this x-axis. So here's your reference angle here. Let me zoom in a little bit so you guys can see that this is theta sub r. In quadrant 3, your reference angle is between the terminal side and your x-axis here. And in quadrant 4, your reference angle is between the terminal side and your x-axis up here. And that's how we've been drawing in our triangles. The really important part about reference angles, here's the whole page so you can get it in your notes or take a picture or whatever you need to do, is that if you weren't given the unit circle, which trust me, if you were in regular class right now, I wouldn't be giving you the unit circle to find these. You could figure out what your values were or what your angle was because you know what special right triangles are. So down here, just a little note, if you didn't already notice, all of my reference angles are acute angles no matter what quadrant the angle's in. And we use these reference angles and special right triangles to find coordinates for x and y. And then we also use what quadrant they're in to know whether those values are positive or negative. That's what that bottom statement says. All right. So, using that information, determine the reference angle for each rotation given, then find the associated point on the unit circle. So you could draw these out. I'm going to draw out A, or you could use your unit circle. So in A, 5 pi over 6, that's just a little bit less than pi. So I'm think it's all the way over here in quadrant 2. And you can confirm that looking at your unit circle. So this here is my 5 pi over 6. Well, this full section all the way to 180 degrees is 6 pi over 6. So, because it's just pi, so what's the difference here? Well, my reference angle that fits in there has to be just pi over 6. So theta sub r is pi over 6. We never write angles as a negative. So as far as reference angles, they're always written as a positive. And then because this is 30 degrees here, my short side is going to be the y and my long side is the x. Here's your x and here's your y. So the long side in quadrant 2 is negative. And it's always negative root 3 over 2. And the short side in quadrant 2 is positive because my y values are positive. So then I would have a positive 1/2. All right, so 7 pi over 4, you will notice that is in quadrant 4. It's one of my 45-degree angles. So my reference angle between here and 2 pi is just pi over 4. Because you can think of it this way, is that if I count my pi over 4s around my unit circle, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So what's the difference between 7 and 8? It's just pi over 4. So my reference angle here is pi over 4. I know that's a 45, 45, 90 triangle. The only values for that is the root 2 over 2. So in the fourth quadrant, I know that my x values are positive, but my y values are negative. All right, 39 pi over 4 is a little bit harder because we have to figure out what the coterminal angle is. So we know that 39, or 4 goes into 39 at least 9 times. So I know 4 times 9 is 36. So 36 divided by 2 pi means it went around 18 times. But how much more is the last, what do we have between 36 and 39 pi? So 36 pi is 9 times around. And then we have 3 pi left. So then we have plus 3 pi over 4 more than 36, or than all those times around my unit circle. So 3 pi over 4 is there. Here's pi. My reference angle would be between this terminal side and the x-axis. That's 45 degrees. So my reference angle here is pi over 4. And I can see what my values are for x and y in the quadrant 2 is, I'm having focusing issues, it's this negative root 2 over 2 because x is negative in quadrant 2 and y is positive. So my values here are negative root 2 over 2 and a positive root 2 over 2. Right. Go ahead and pause if you need to finish getting this in. This is the last slide of this lesson. We'll continue on the next task, building off of this.